All right, we've also done this problem before. So I'll give you V Thevenin and Z Thevenin, and I want you to finish it. V Thevenin is 18.97 with an angle of 71.57 degrees. That's RMS. And Z Thevenin is 0.5 plus J, 0.5 ohms. And that's RL plus JXL. Find the load for maximum power transfer, and then find the value of that power. Find the load for maximum power transfer, then find the value of that power. And our theory was, if for maximum power transfer, Z load must equal Z Thevenin conjugate. So it's 0.5 minus J, 0.5 ohms. Did everyone make it that far? Then the value of that power is the magnitude of V Thevenin RMS squared divided by 4 RL. So that's going to be 18.97 squared divided by 4 times 0.5. How are we doing? What is the maximum power? What is the maximum power? 181 watts. Did anyone else get 181 watts? All right, very good. So V Thevenin is 500 with an angle of negative 90 degrees. So for this last problem, V Thevenin is 500 with an angle of negative 90 degrees. And once again, we're assuming this is RMS. Z Thevenin is 100 plus J 50 ohms. And this is actually a problem you could solve with source transformations. So you could use source transformations to get those two values. Find the load for maximum power transfer, and then find the value of the power. Find the load for maximum power transfer, and then find the value of the power. $100 minus J 50 ohms. Very good. Okay, what's RL? What's RL? $100 ohms. So ZL is 100 minus J 50 ohms, but I know this is RL plus JXL. So RL is 100 ohms, and if you ever needed XL would be negative 50 ohms, but you don't, right? So P max is the magnitude of V Thevenin squared over 4 RL. So this is 500 squared over 4 times 100, 625 watts.